This is an example of the application of normal distribution. In this problem, suppose you sell a brand of automobile tire that has a life expectancy that is normally distributed with a mean life of 30,000 and a standard deviation of 2,500 miles. You want to give a guarantee for free replacement of tires that do not wear well. How should you word your warranty if you are willing to replace approximately 10% of the tires you sell? So let X be the life expectancy of tires in terms of mileage. Then we know that X is normally distributed, and for a normal distribution we know there's a mean mu and variance sigma squared. The mean is 30,000 miles and the standard deviation is 2,500. So we can write this as X is normally distributed with mean 30,000 and standard deviation 2,500, and so the variance is 2,500 squared. What this information means? Let's recall some information regarding normal distribution. We know that 99.7% of the data lies between 3 standard deviations away from the mean. That means the percentage of data lies between mu minus 3 sigma and mu plus 3 sigma is 99.7%. Likewise, we know 68% of the data lies between 1 standard deviation away from the mean, and 95% of data lie between 2 standard deviations from the mean. But the most important one is they give you that 99.7% of data, almost all the data lies between mu minus 3 sigma and mu plus 3 sigma. What does it mean now? Using mu is 30,000 and sigma is 2,500. After the calculation, we know that 99.7% of the tire will wear out between 22,500 to 37,500. So from this, we can see how do we put a guarantee. So you can word the guarantee this way. If the tire wears out before how many miles, the customer will get a free replacement. So how should you put the number here? Should you put a number 50,000? Now if you put a number 50,000, this is very unrealistic, because that means that every customer who buys the tire will get a free replacement, because tires most likely will wear out before 37,500 miles. Almost every tire, 99.7% of the tire will last between 22,500 miles to 37,500 miles. If you put this guarantee, most likely the company will lose money. And most likely bankrupt, because every customer will get free replacement. So this is not a good number. How about if we reduce to, let's say, 30,000 miles and get free replacement? Now if we put 30,000 miles, you'll see from the graph below, 50% of the tire will wear out before 30,000. So this is not very good, because half of the customer will get free replacement. So how should we find the T now? Where T, so that you are only willing to replace 10% of the tire. That means that only 10% of the customer will get free replacement. That means that The green area here is 0.1, and therefore the area between this T and the center mu is 0.4. Now, in order to find this T here, we want to find the probability that the life of tire less than T is 0.1. Now we have to convert to Z first. Z is x minus mu over sigma. Therefore, this is Z. This is the probability of Z less than T minus 30,000 over sigma 2,500. And want this probability equal to 0.1. Now you look at the standard normal graph. Center 0, standard deviation is 1. I want to find the Z here. The area on the left of Z is 0.1. And therefore, the area between Z and 0 is 0.4. Now you can use the table to find out what is this area. First, we find out that this area 0.4 and you find that based on the table, if you want the area 0.4, you find that the nearest area you can get is here, which is 0.3997, and this happens when Z value is equal to 1.28. That means that this value is 1.28. Therefore, since our Z is on the left hand side, this is minus 1.28. So the number we're looking for now, I want the area less than some number, this number, which is T minus 30,000 over 2,500 is equal to minus 1.28. And so we solve for T, and we get that T is equal to 26800 miles. That means that if you put a guarantee at 26,800 miles, then you only have to replace 10% of the tires that wear out.